Today we are going to start on the topic collections. Right? Collections. So this is basically a advanced framework for the arrays. We had already seen how the arrays can be used, right? What is the purpose of the arrays, right? Still there are a lot of limitations in the arrays. So that's the reason we had got to something like collections. Right? Let's write some notes for the collections. Let's create a package first for the collections. Package collections create notes. So this collections is basically to overcome the limitations of the arrays. First, let's try to understand what are the limitations of the arrays. Array size cannot be changed. Cannot be changed. Once we define it, throughout the life, the same. Cannot change it. Arrays can store only one data type of elements. Okay, one data type of elements. Cannot store multiple types of multiple data types of elements. Is integer can store only the integer elements. Okay. Not byte, short, long, float, double, char, string, etc. So vice versa. Okay. For example, you create an array of type byte, you cannot store the integer or any other data type. Managing the elements of an array is difficult because it doesn't provide any built-in methods. So there are not many methods which we can use. How to overcome all the whole limitations of the arrays, we have collections API. Collection API. All the collections, classes, and interfaces are available in Java.util package. Java.util package. So basically, collections API is divided into four parts. One is list, second one is set, third one is queue, fourth one is app. Fourth one is map. So, are all the points are clear, or should I go through each and every point here? It is very simple. We had seen how the arrays can be created and then worked on, right? So there are certain limitations. At the time of creating the array itself, we need to define the size. Once we define the size, we cannot change the size later. And also, if we create an array of type integer, you cannot store the elements of any other data type. And there are no built-in methods to manage. For example, if you see string class in the last couple of classes, there were a lot of inbuilt methods, right? For example, sort method, substring method, split method, right? Uppercase, lowercase, all such methods were there in the string class, but there are no such methods in the arrays to manage. So to overcome all these limitations, there is something called collections API, which is introduced in JDK 1.2, right? Basically, all the classes and interfaces of the collections API is available in the java.util package. On high level, collections API is divided into four parts. One is list, second one is the set, third one is the queue, fourth one is the map. Okay, I want to show one diagram. Let's see if I can find it on Google. Hierarchy in Java. Yeah, you see this diagram? Is it visible for everybody? Yeah, it is visible, right, for everybody? Or should I increase? Should I zoom in?
No, it is visible.
Okay, all right. So I was saying collection is divided into four parts. Here you can see three things: list, queue, and set. The first three things. Okay. So basically, this collection class is subclass of the iterable class. Iterable. Okay. Here you can see the color coding also. Whichever is in the blue color, it's an interface. Whichever is in the green color, it's a class. Okay. So here interface is the iterable is the interface. Okay, that has another sub interface, that is the child interface, that is the collection interface. That collection again internally has three parts. One is list, queue, set. Under list there are four classes. So whatever you see in the green color are the classes: array list, linked list, vector, stack. These are the four classes. Under queue there are three queues. One is the priority queue, array DQ, and DQ is something which is a combination of list and queue. So under queue we have priority queue and array DQ. So simple DQ is a combination of list and queue. That's the reason it is in the between, it is in the middle, and then there are some arrow marks. Right. Then the third one we have set. Under set there are two classes, hash set and linked hash set. Right. And there is one interface, that is a sorted set. So under sorted set that has a subclass, that is a tree set. What is the tree set? It is very easy to remember which comes under list and which comes under queue and which comes under set. Whichever class ends with set, all of them will fall under set. Whichever thing falls under, whichever ends with the list, right, all of them falls under list. And there are two extra things, that is vector and stack, not a difficult thing to remember. These two falls under list, and all the things whichever ends with the queue falls under queue. Right, it is very simple. Now I was saying there is one more part, right, the fourth part, the map. Let's see where it is. Map hierarchy in Java. Yeah. So this is the hierarchy for the map. So here the color coding is slightly different, but it doesn't matter. Map is the interface, right, which has a sorted map and hash map. Two things. It has one interface and one class. Right. So sorted map has further extended with the tree map class, and hash map has further extended with the linked hash map. See, all the classes are interfaces as part of the map, ends with the name map only. So it is easy to remember. Okay. These are the four parts that we need to learn. Now we are going to learn each and every class or interface one by one. Okay, first we will start with the list, then we'll go to the set, then we'll go to the queue, then we'll go to the map. All of them are very very important. You won't see, or once you get a job on this, there is no day where you don't work with this kind of things. On every daily day to day basis you will work with this kind of concept, this concept, right? So it is very important to understand, and in fact, it is very easy also, not a difficult thing, right? Let's write some programs. So list comes under. I'll just quickly write it here. A list, linked list, vector, and set hash set hash. These are only two classes, right? Hash is is parity queue, ADQ, map, hash map, linked hash map, tree map. So I'm just writing only the classes here, not the interfaces. Let's first start with the array list. SVM array list. See, it is already available. Right? It is in the java.util package. Array list equal to new array list. I'm not doing anything, guys. I'm just creating the object for the class array list. The name of the object is list. That's it. List dot. There are so many inbuilt methods are available here. Okay. We'll learn one by one. First, let's start with the list dot add of 100. Like list dot add of 200. Dot add of 40. Dot add of list dot add of 20. Dot add of etc. Dot add of 2. Dot add of 0.0506, whatever it is. So this list we could add different types of elements. These all these things falls under int, and this is a string, this is a boolean value, and this is either double or float, whatever it is. Right? I'm just printing the list now. Run the program and see the output. See, we are getting the same elements in the same order, right? The order also is not changed, right? 100, 200, 40, 60, 20, ABC, 2 and 10.06. Clear? Why we are getting directly the data? Because toString method is overridden in the ArrayList class. You can just hold Control and click on the ArrayList class. You can see the implementation of the ArrayList class here. You will see the toString method already overridden somewhere. Okay, you can check it later. It is very huge class. Okay, it has around 2000, almost 2000 lines of code. Okay. Now let's see the other methods, right? That's out of list dot get of. See, there is a method available get of where we need to pass the index. Get of 0. So indexing always starts with 0, right? So what is the element that is at the index 0? 0th index is 100. First index is 200. Second index is 40. So it is the same sequence and same indexing. Right? Let's run and see the output again. 08 index is 100, first is 200, right? Likewise, we had got put everything. Only the seventh index I did not put. That's okay, right? That's out of list size is plus list dot size. There is a method called size. So this will give the size of the list. Size of the list is how much? I think we had done sixth index and seventh index, right? That means I think eight elements are there. One, two, three, four, five, six, seven, eight. So we should get the output as eight. List size is eight. So you convinced with the first statement here, array size cannot be changed. Once we define it, throughout the life, it will be same. Here we are not defining the size. Likewise, you can keep on adding the elements of even 1 million elements also it will accept. It doesn't give any error or exception. You can add as many number of elements as you want. Clear? Now let's use the enhanced for loop. Usually in the arrays, if you want to iterate over the array, what were we using? We were using either for loop or the enhanced for loop. Going forward, we'll be using only the enhanced for loop. I just put iter, then enter. Automatically, I'll get the list here because list is the one which can be iterated here, the latest one, right? Oh, here we are putting the object. Please have a notice on this one, right? Please be noticed with this. Now we are getting object. Going forward, we'll see the different things, but we'll understand why it will be different, right? It's stuck. All right. Yes, out of four. So we could print again all the elements through the loop here. This is inside the for loop, the enhanced for loop. Okay. Another thing, let's say for example, I want to get the value, I want to get an element from the list, right, and assign to a some variable, right? So I will say list dot get of two. I will say I'll just I don't know the data type of this object, right? Because let's say in this list there are 1 lakh elements are there and all of them are different things. But I just want to get an element which is at the index 2. So I just put it this one, select Control Alt V, right? Get object. Right? So everything will be a object here because we did not specify anything. Sort of so say for example string. What is the index for the string element here? 0, 1, 2, 3, 4, 5. Right? List dot get of Control Alt V O1 out of O1. In case if you know that the element at fifth index is string, you can do something like this. String s1 equal to list dot get of string. This will give the error. If you click on the bulb, you will see cast to java.lang.string, the topic that we learned during the typecasting, right? This is the typecasting because list.get we are getting the object type, but we are trying to assign to string, so it has to be typecast. That's the reason we have to put this typecasting here. Now, if you want, you can print this as one. ABC, ABC. Let's see some more methods. List dot. We have seen get. We have seen size. We have seen add. We had, let's see, add of int index comma int index comma object element, right? Let's see how it works. Int index I will pass 3 comma I will put x y z. What it does is we are going to add an element xyz at the index 3. What is the element that is at the index 3 now? 0, 1, 2, 3, that is 60. Okay, so currently we have the element of 60 at the index 3, but now we want to put xyz. If I print it now, out of list, xyz will go in between and 60 will move to the fourth index. See here, xyz, and then again it is the same old sequence 60 20 abc 2. It's just like there are 10 people are sitting in a row. If a new person comes and sits in between, all the other guys has to move further right, move sideways, right? It's exactly the same thing, nothing else. So wherever, if you want to insert any element in the list, in whichever position that we want to insert, we can do that. Now let's see some other method. List dot add all will come back here. Clone contains, so it's the contain. List dot contains of input abc. So this can be put into yes or it will give true or false. That means whether the list contains ABC or not. Our list contains ABC. Yes, true. You should get the true. If it doesn't contain, it will give false. Let's see another method. List dot ensure capacity not much required, for which we know hash code. Yeah, index of, right? We had seen the index of method in the string class also, right? Yesterday, it's the same thing. Next, list dot is empty. You just check. It will give true or false, right? Whether the list is empty or not. If it is empty, it will give true. If it is not empty, it will give false. So our list is empty now. No, it's not empty. That's the reason we get false. We have a lot of elements. list dot the methods last index of we had seen, right? Remove. Let's learn about the remove of ABC. Now we'll print the list again. Earlier we had the ABC in our list, but now in the final print ABC should not be printing. See, ABC here we had ABC here after 20, and now here ABC is not there because we just removed the ABC. So we can remove the element by using the remove method. Dot. Similarly, you can do the remove all. That means you can remove everything. Remove F will come later. Replace all. Replace all the elements. Retain all will come back later. Set. List dot set. It is nothing but add of index and some other element, right? Let's say for example, I will put again 3 and then this time MNR. So what is the element at the index 3 now? It is 0, 1, 2, 3. That is XYZ, right? So now MNR should come in place of XYZ and this should move to the right side. Let's print the list and then out of think no, it will not move, it is actually replaced. Let's see. But we don't use this method. Yeah. XYZ is replaced with the MNR. By using the set method, we can replace it. List dot sort. For sorting, this will not work now because we have the different types of elements, right? When there are different types of elements, we cannot sort. So split iterator, we'll do it later. Sublist. Sublist is nothing but just like a substring, right? Yesterday we were seeing the substring from string, right? Sort of list. Or I will say 2 comma 4. Means I want to create a list from second element from the element that is at the second index to fourth. Again here it's the same formula. Begin index is inclusive, end index is exclusive. We are not printing the sub, we should print this one. See 2 comma 4 0 1 2 2 is what 40, 3 is MNR and fourth is 60. 60 is the exclusive, the end index is always exclusive. So you will not get the element that is at the 4. That means 4 minus 1 3. So you will get basically second and third. List dot all these stream things are comes under as part of Java 8. That is a separate topic we'll learn later. To array. List also can be converted back to array. Sort of to array. See when I convert it to array, it is giving some hash code. List dot toString is there. It is already overridden. You can try that very common thing. These are the methods which are in the array list, and whatever you see that starts with the stream, right? All of them are the Java 8 version related methods. That is a separate topic. We'll learn separately. First, let's learn the basic collections. These are the various methods available in the list. There were few methods which we skipped, right? Let's learn them. For them, we need two different lists. That's the reason. Copy paste the same one. Shift F6 so that it will be listed to. Should write it in the right. Now I'll write another list here. It's going to be the list one. Okay. So here I will say 2000, 4000, 6000, 20,000. This is the XYZ. It calls 100.06. So now there are two different lists, right? Sort of list one is plus list one. Similarly, I print list two. From the program, see. Right? List one and list two. Right? Now the methods that I wanted to show you is list one dot add all of collection. See? Add all of collection. So that means I need to pass another collection here, that is list two. Okay. Now if I print list one, so it should get both. So we are adding all the elements that are available in the list 2 to list 1. So now list 1 should have everything. See, list 1, list 2, and after adding, this is the single list. Okay. So here you can put the comment saying that list 1 after adding list 2 in it. Now if you want to add all the elements from list 1 to list 2, right? List 2 dot add all of list 1. Can somebody tell me what will be the output now? I know it will be a lot of elements, you cannot tell, but my main intention is how many times list 1 will come, how many times list 2 will come. See, in the list 1, let's run the program and then see the output. See the output. List 1 after adding list 2 is this much. List 2, that means, but list 2 is remaining same, the old one. We are not adding at this step. But here we are adding list 1 to list 2. Right? So list 1 is what at this moment, here at this stage. This whole thing is the list 1. right? So you see, first list 2 will be there, right? And then after 100.06, you will see list 1 as this one. You see, hope it is clear, no confusion. Clear? Now let's see other method. List 1 dot remove all. Just like add all, we have the remove all also. The list 1 dot remove all of list 2. Now list 2 has become very big, right? I think this is, let's not, what I will do is create a separate program. Then let's not have too many elements. Okay. That it will be one dot remove all of list 2. Right. So here I will say just 100 I will put, and then ABC XYZ. List 1 has this one and list 2 has this one, and after removing list 2 from list 1, we are removing list 2 from list 1. So whatever the elements were there in the list 2 should be removed from the list 1. That is the final output. So 100 was there, right? So 100 is removed. So 200 was there, 200 is not there in the list 2, so that is not removed, right? And then ABC was there in the list 1? Yes, ABC was there. So ABC is removed, right? So likewise, you can see the elements. List 1 dot remove all of list 2. So whatever is there in the list 2 should be removed from the list 1. So that means the common elements in the both the collection should be removed. Is it the right answer or not? I am a bit doubtful. From list 1, we need to remove the elements of list 2. So 100 can be removed. 2000 cannot be removed, right? 200 had come. Okay, we are not printing the list 2, we are printing the list 1, right? After removing. So 100 is there in the list 2. So 100 is removed, 200 is not there in the list 2. So 200 will come. Then ABC is removed. Then true or false, true is not removed. Then 10.6 is not removed. Clear? Yeah. Let's see some other methods. List 1 dot add all, remove all, we have seen, right? It's something called retain all. Retain all of list 2. For this, we need to write a separate program. This is copy paste. list one dot retain all of. So let's keep some. Okay. Yes, out of, out of, next to. You see the difference now? List one dot retain all of list two. Retain means just keeping it as it is. So that means whichever is common, we are keeping it in the list one. All non-common things we are removing. In the previous example, in the remove all, we were removing the common things, but here we are keeping the common things. We are keeping the common things. That's the difference between retain all and remove all. There is one more method. All we have seen is all contains all. So if exactly both the lists are exactly same, then we will get the true. Contains all. That means all the elements that are available in list 2 are containing or in list 1 are not. So obviously there is a difference between the two lists, right? We will get false only. It's not that sometimes list 2 can have everything, okay? 100, 200. I'll just put something like this. Or what I will do is I'll create another program, because once we are modifying the data, right, the same data is not useful. I mean, it is getting a bit difficult to understand the next method that we are trying to understand. The lists are getting modified, right? So yeah, 200 ABC have two, right? Now between somewhere I'll add list dot add of and right, add of. So now list 2 has all the elements that are there in the list 1, and in addition to that there are two more elements, right? If I use the same method now, contains all of list 2, we should get list 1 dot contains all of, no, here it should be different, list 2 dot contains all of list 1. So we are checking second one in the first one, not the first one in the second one. So we should get true now. See, true. Because whatever the elements that are there in the list 2, what are the elements are there in the list 1 or in the list 2, and in addition to that there are some extra elements also, that doesn't matter here, right? That's the difference. Next I will write another program. Yep. So now this, right? I'll put 1000, 2000, ABC, XYZ, false, 0.06. So we had seen add all of, right? List one dot add all method. There is another add all method which takes an index and then the collection, right? Let's see. We'll put 3 comma list 2. What happens here? The sort of list 1. So we are adding the list one list two to the list one from the index three. If you don't specify the index, it will add in the end. If you specify the index, then it will add at this index. So what is the element at the third index? 0, 1, 2, 0, 1, 2, 3, right? So from 3, you will get the list 2, and again after that you will get back these two elements. Let's see this. List 1 is this one, list 2 is this one. Now again list 1 after element, after adding it, see here you can clearly see the list 1, we are adding list 2 here to the list 1 from the third index, 0, 1, 2, 3, and again it is common, the further elements it is common. Once it is done, list 2 is completely added, then we are getting this. So whichever index you want to insert, you can insert that particular thing. Clear? I think these are all the methods that we have covered almost, right? How to retain, how to model, array, subarray. Yeah. If you want to clear the list, you can use the clear. Clone is nothing but the copy. Ensure capacity, just to check the capacity of the list. That's okay. That is not an important thing. This list iterators and all we'll learn later again. Split iterator also same thing, and the stream also same thing. Just clear we'll learn. Sort of. Now we should pick 0 elements because list 1 is cleared. See, it has become empty because we are just clearing all the elements that are there in the list 1. Okay. So these are all the various methods are available in the list, right? The array list. We'll see some more flavors of array list tomorrow. Okay, the methods are same, the behavior will be same, but we'll try to put some more depth concepts here. Cool. Any doubts, guys, so far?